Hello everybody, welcome back. These notes are going to be for Thursday, April 23rd. However, I will upload them Wednesday night so that you guys can get a head start on your math work. Today we're going to be dealing with scatter plots notes 9.1, which is the second page in the notes that I sent you. If you guys printed them out and are following along, then that is great. If not, then I will also have the written notes on Google Classroom so that you guys can refer back to them when you guys are doing your assignments. So scatter plots, we're going to go back and revisit the idea of graphs. However, if you notice, there's a lot of dots and a lot of kind of bubbles around this page. We're not dealing with lines necessarily. So with scatter plots, we're dealing with data that involves measuring two different things. We're going to start by measuring bivariate data. What this is data with two variables like height and shoe size. So if we have a table, on the x-axis we might have height, on the y-axis we might have the shoe size. And that's exactly what we have over here on our graph. Our x-axis might be shoe size, our y-axis might be height. So that's not exactly what the graph is stating, but that's just kind of an example. So before we get started, we have to kind of label some stuff and know what we're dealing with in some of these notes. One thing I want to start by labeling is noticing that all of these points over here that I circled for you are kind of bundled up all together. We call that a cluster. And a cluster, that's supposed to be a C. A cluster is a bunch of points or data, as we're dealing with, mumbled all together or put all together. We also have something called an outlier. An outlier is a point that is all by itself. So it is a point all by itself. Let's get into what types of association we're going to be dealing with, or what types of data. In other words, in statistics, we call this correlation. Correlation, data, and association mean the same thing. So let's look at the first one. First, we're going to deal with something called a positive association or a positive correlation. We call this a positive because if we look at the x-axis, as the x-axis increases, the y-axis is also increasing. So as x increases, y increases. And if you remember from when we graphed lines a while back, we always wrote or drew our line and wrote on the graph whether it was a positive, negative, undefined, or zero slope. Well, you can do the same thing with these types of data. If we look at our points, this is going up in a positive direction. So we know that our data or our correlation is going to be positive. With that being said, I'm sure you can guess what our second type of association is going to be. Our second is going to be a negative. What this means is as x increases, y decreases. So as x gets bigger, y is getting smaller. And if we do the same thing that we did in the first graph and kind of follow our data, we notice that our points are going to be going down in a negative direction. The third type of association that we have is something called no correlation. what this means is that this does not make a line shape. We have a bunch of data points all around the graph. So this means that it does not make a line shape. Let's look at linear versus nonlinear. In this graph, we have a linear graph because we have a bunch of data points going in a straight line. If we follow this data, we can create a line going up. However, if we kind of follow the data in our second example, we notice it kind of makes like a curve. But regardless of whatever shape this is not a straight line, so this is not linear. Not linear. Let's look at some examples. Number 1, interpret the scatter plot of the data for the amount of memory in an MP3 player and the cost based on the shape of the distribution. So let's look at our graph. First thing we want to do is kind of look at the points and see if we can make a line anywhere. Well, it doesn't look like the no correlation graph because we do have our points in some sort of shape. Our points are not necessarily going down because we're always starting from our origin. However, they are kind of increasing. So because they are increasing, we can draw a line going straight up. And we know that lines that go straight up are positive. So let's write what we know. We know that this is a positive correlation. And we know that it is linear because it makes a straight line. So what this means for our answer is, because our X, we're talking about memory or gigabytes, and our Y, we're talking about the cost of those gigabytes. In conclusion, we can say that as memory increases, the cost increases too. And we can see that because as X is getting bigger, Y is getting bigger. So as X increases, Y increases. But in this case, our X is our memory and our Y is our cost. And this makes sense because the more memory that you buy, so let's say you're buying a phone or a flash drive, the more memory it holds, the more expensive it will be. Let's look at example 2. Interpret the scatter plot of the data for the time elapsed and temperature of water based on the shape of the distribution. So let's go to our graph and see what kind of line we can make. Well, it's not clustered. It's not randomized like a no correlation. It's not necessarily going in a positive direction like the first example was, but it is going down in a negative direction. So let's go ahead and make our negative line. And then we have to write what we know. So we know that this has a negative correlation. We know that this is linear because it's making a straight line. So let's go ahead and justify our answer. So we can say that as time elapses, and elapses just means passes, so as the more time passes, which is our x value, the temperature which is our y value, decreases. So what this means is that the more time passes, the colder it is getting outside. And I will have justifications on the sides written for you on my notes so that you guys can see what I mean when talking about these graphs. Number 3, interpret the scatter plot of the data for 2 weeks in May and the amount of ice cream sold at a shop based on the shape of the distribution. So if we look at our graph, well, it's not really going in a positive direction because if I go straight up, I still have all of these other points on the sides. It's not really going in a negative direction because even if I go this way, I still have all of these random points on the sides, which means it has to be no correlation. And we know that because it looks just like our no correlation example. All of our points are scattered. So we can justify this. What this means is as the days continue, there is no relationship with the number of pints sold. So as the days continue, and our last point goes up to 14 days, which is about 2 weeks, there is no relationship with the number of pints sold. So we don't know how many pints were sold within those 14 days. Okay, so before I finish this video, I want to show you the worksheet that I posted for you. It looks like this, and the directions say, determine if each scatter plot has a positive, negative, or no correlation. Draw a line of best fit. I want you to ignore the part that says draw a line of best fit, because that is what we will be doing in our next lesson. So we don't know what a line of best fit is right now. So what I want you to do is look through each example and just tell me if it is positive, negative, or no correlation. And I will go ahead and do the first one for you. So let's number them. 1, 2, 3, 4, 5, 6. And then you can number them going across if you'd like as well. So for number 1, if I want to draw my line on my graph, starting from the origin, which way is it going? Well, it's going up. It looks just like our positive slope. So we know that this is a positive correlation. So that's what I want you to do for all of the examples. Just kind of familiarize yourself with whether the data is positive, negative, or no correlation. And let me know if you have any questions, and I will be right beside my phone and my computer to get those answered for you as quickly as possible.